We have the layout of the widgets we're going to use and the assets they need to communicate their functions and value. There's quite a bit to get through to get everything talking to each other and changing the settings of how we are experiencing this in real time. Let's get started. Start in our BPP pawn darts. While we didn't set up the spawning logic of the hood in the parent, we will still call this function in the parent so any additional pawn could take advantage of it later. Create a custom event called UI_core button pressed. Give it two inputs. The first called button action of type eButtonAction and the other named value of type struct user settings temp. User settings temp. Naming this value. Compile and return to motion controller pawn darts. Right-click and search for event UI core button pressed. Promote the value to a variable named temp values from user settings and attach that to a sequence node. Sorry, not settings, UI. From then 0, create a switch on eButtonAction node. Plug button action from the event to the selection of the switch node. We're going to receive the value of button action from the button itself. The action and the value will be sent where the button is used, so we are telling the pawn to take those two variables and, depending on what the button action is, do something with the value you've received. In then1, call the core button pressed event inside of BP hood. Calling this event will tell the blueprint that is holding the widget to communicate back to the widgets so they can decide what to do with this new data. Before we have anything happen here, let's set up the button and widgets first so we can then see the effects when we are done with these settings. I'm going to make a print string node in a new sequence pin so I can make sure things are working. I'll also create an append so I know what the button action and the values are. Now open up wcore button. It is in the reuse folder inside of the UMG folder. At the top right, open the graph. We need to add instance editable variables here for us to change as we use them. Create a new variable named button action and change the type to eButtonAction. Remember to set instance editable to true. Create another called value and set it to a struct user settings temp. Also be sure to set instance editable to true. When we create the interaction logic in the player pawn shortly, we'll be calling a function that imitates pressing the pointer key. So for the button, what we want to do is send this data when it is specifically pressed. Select button, core button, and add an onPressed event. Right-click on the graph and search for getPlayerPawn. Cast to BPP pawn darts and call UI core button pressed. Plug our variables into the correct inputs and compile. For us to interact with our touch controllers, we're going to be using a widget interaction component. We could then tell it the source of the interaction, which in our case will be our motion controllers. Add a widget interaction component and make sure to attach it to the camera. As the camera moves or rotates along with us in VR and brings the hand with it, we need to make sure that everything stays lined up correctly. Before we continue, we need to add our inputs to the project settings. Open the project settings and navigate down to Input. Create two new action mappings, Interact with Widget Right and Interact with Widget Left. It's pretty common to interact with our UI and VR using the triggers, so we're also going to be using the touch triggers for this event. Set interact right to Oculus Touch R trigger and the other to Oculus Touch L trigger. Be certain to choose Oculus Touch R trigger and L trigger and not trigger axis or trigger touch. Those will produce effects that we're not expecting. Return to Motion Controller Pawn and create these two events. The first thing to plug in is a branch that is asking if user HUD visible is true. Then, on both hands, set the HUD using right hand variable appropriately. So on right, I'm going to set HUD using right hand to true, and on left, I'm going to set it to false. Pull in a reference to our widget interaction component and call the function press pointer key. Set the key value to left mouse button. On the release event for both hands, from the widget interaction, call release pointer key from both hands. We won't add a branch here just in case the user HUD hides before we can call the release pointer key. That could potentially cause issues. We now need to tell the widget interaction component how to interact with the widget. Select the widget interaction component and set the interaction source to custom and set widget interaction distance to 300. To calculate the custom interaction source logic, we'll use a line trace from our hand and trace it forward 300 centimeters. Create a custom event called getCustomHit for widget interaction. I know that's a long name. Widget interaction. Right-click and search for line trace by channel. Working backwards from start, get the world location of the motion controller within our left controller. I need to get the motion controller. World location from the motion controller. And plug this into start. Detach the left controller variable and move it over. From target, create a select node and plug HUD using right hand into the index. Plug left controller into false and right controller into true. With this select node addition, the custom source can change the source in real time if we switch hands. From motion controller, get the forward vector and multiply it by 300 and add the result to the world location. 300. And then we're going to add the result to the location and plug this into end. While there is an option to see the debug line we are making from the widget interaction, I find that to be a bit too thick of a line. Instead, I'll set draw debug type on the line trace to for one frame. Get a reference to the widget interaction and call the function setCustomHit result and plug it into our line trace. Let's call this after our smoothly move HUD event from the event tick. Yep, this interaction. Okay, let's test this. Remember, nothing yet will change, and all we're looking for in this test is if it is communicating. We're looking for the interaction. So if I turn on the widget, now you can see the line trace from our custom hit, and it is hitting the widget because you could tell that by the line changing from red to green. If I press the interaction, I can change to a cast from my right hand. And if I press any of the buttons, what I'm looking for, and there it is the print. So now I do know that I'm interacting with that button because I'm getting a print to screen. If you're unable to see the print to screen, you can always open the output log to find it. And here's mine. It says menu left 0, as in the value of the integer is 0, 0.0, the value of the float is 0, and the linear color is all 0. So that was exactly what we wanted. I'm going to keep that print string in there for now just in case. Let's get this all set up and working properly. From that long switch node, let's start at the top and work our way down. Menu left and menu right will be taken care of in the hood. Open BP hood and then open WP user hood. The arrows at the bottom are responsible for cycling the pages. Right-click on one of them and select Edit Widget Blueprint. Looking in the designer, notice that even though this is a different button, we'll still use the W core button. In the graph, create an event construct. This is UMG's version of event begin play. We need to tell the button what action it should take when pressed. Drag core button in and set the button action. From button action, search for a select node. Create a new bool variable named button right and make it instance editable. Plug button right into index. Set true to menu right and keep false on menu left. Compile and return to WP user hood. Select the right arrow and set button right to true, and open the graph. Create an event construct and get a reference to the widget switcher hood. From widget switcher hood, search for get children count and then subtract by 1. We need to remove 1 from the total children count because our cycle logic will account for 0 as a child. If our switcher has 3 children, the result of get children count will be 3, but we'll be cycling from 0 to 2. Also 3 children, but starting at 0. Create an integer variable named number of children, then duplicate the variable and name this one current menu. We need to create an event to handle the cycling logic from these 2 buttons. We're going to take the number of menus we have, and if going to the right, add the index to this amount. When we reach the end, go back to 0 and start over. If going left, we'll subtract, and when 0 is hit, we'll go to the end. Create a custom event named change menu with one bool input named right, and connect it to a branch. Starting at the true branch, create another branch and set the condition to current menu is greater than or equal to number of menus. Just realized we never set number of children. So we want current menu is greater than or equal to number of children. And if true, set current menu to 0, and if false, increase current by 1. If going left, create another branch, and the condition is if current menu is less than or equal to 0. If true, set current menu to number of children. While we're here, I think number of children is not the best variable name. I'm actually going to change this to number of menus. And if false, decrease the value of current menu by 1. Get a reference to the widget switcher, and from all 4, call the function setActiveWidgetIndex and plug current menu into index. Now create the core button pressed event with the same 2 inputs as the others. and value. Temp. Again, save the value to a variable and plug the button action into a switch node. From the top of the switch node at menu left, call change menu, and from menu right, call change menu with right set to true. Remember to call this event from BP hood. Let's test and cycle through all the menus. All right, so I'm going to spawn the menu, and using my right hand, I'm going to press the arrows. And there we go. So I'm not seeing any, there's no pause, so all the logic is working. I could cycle now through all the menus. We're now using our Oculus Touch controller to tell our motion controllers, to tell our pawn, to tell our hood, to tell our widget that we want to tell our pawn, to tell our hood, to tell our widget, to cycle our menus. Communication. Okay, let's finish this setup in the next module.